Okay, so we've got this input from the external world. We've, used figure ground kind of notions, grouping things from Gestalt principles, and we have a sense of where, or at least what defines specific objects in the real world. Now we want to figure out what those objects are. What do we do now? Let's see. All right, so I decided, here we are, sorry, perceiving what? Number 2, week 3, lecture 4. I threw on this annoying, there's some annoying figures like this. They're called impossible objects. And when you look at it, it looks possible enough until you start really kind of thinking it through, and you realize, well, wait a minute, this line can't go behind that line, and it kind of annoys you a little bit because it looks good, but ultimately it doesn't pass the test when you look at it in detail. So this just kind of shows some of the complexities that our perceptual systems have to deal with. All right, so let's jump in. Here's a scene. Depending on how clean you keep your place, it may be a good or poor representation of a table in your household. But if we just look at this quickly, wow, look at all the objects. Okay, so we use all those principles. Grouping, for example, similarity. We kind of think, okay, this must be an object of some sort. Trying to find something like good continuation. Well, even though we can't see all of this object, I guess it kind of disappears behind some things. We assume it continues on behind there. Even this vase here, for example, we've only got a bit of that, but our perceptual system kind of fills in that this isn't really just a part of a vase. It's probably a real full vase. Similar with this one, actually, which is occluded by that. So we have all the systems kind of saying, okay, there's objects. Wow, there's objects all over the place. There's an object. There's an object. And so let me point to some objects. What's this? What's this? What's this down here? What's this? What's this? No, not really sure what that is. But this one, for example, is a Buddha. And we can look at that and see quite obviously, yeah, that's a Buddha. How do we do that? In fact, when we look at a scene like this, what we see is objects. We don't really see shades of light and lines separating X from Y. We see this bunch of objects. Look over here. Holy crow. What a bunch of stuffed toys, all stuffed into one. And yet we could still go, okay, there's a lion, there's a little doggy, there's a bear, this looks like an elephant. So we can still see objects of a sort. And we do this really effortlessly. It just comes to us this way, which is really cool, really powerful, and something we really don't appreciate until we encounter some people who can't do it that fluently. And then we really appreciate the ability that our brain has to just do this so effortlessly, show us objects. Now, obviously, past experience is playing a role here. I mean, this is memory. There's some perceptual thing that hits our eyes, and somehow that makes connection to previous experiences we've had. So we've learned, for example, that this thing is called a ukulele. I think it's a ukulele. I think that's 4 strings. That's what I would really want to know it's a ukulele. But somewhere we've seen, for example, ukuleles, and somewhere in our mind there exists the concept of a ukulele, and when we see it, we connect with that concept and we recognize what's there, and we do this really quickly. How do we do that? Well, one of the challenges as people have thought about this issue is something called featural variation. So imagine the concept of a chair. And here I've got 6 chairs depicted for you. What defines something as a chair? These two might be more like our prototypical chairs. If somebody asked us to define a chair, we'd probably say something like, well, it has a seat, has a back, and has 4 legs, and you sit on it. That kind of fits that. But look at this thing. I mean, I guess it has a seat and a back. Certainly doesn't have 4 legs. This, yeah, I guess. How many legs does this have? I guess you could call it 4. This is a pedestal. This is kind of 1 leg. This doesn't really, I mean, it kind of has a back, but it has more wings. So there are all these other features floating around here that are perhaps not necessary for a chair. So how can we recognize all of these things as chairs? Or how can we, this is a little bit, okay, it's not subliminal. I was going to say it's subliminal influence here, but it's pretty obvious. But nonetheless, how can we recognize all of those? Look at the S's, for example. They're quite different in these different fonts. This one's got these little tails and such. So we can't just say an S is a squiggly line. Sometimes it is just a squiggly line. Sometimes it's a real fat with barely any squiggle. This one's like all kind of crunched out. And what the heck's this one down here? You see that there's a lot of variability, and yet our perceptual system is very good at handling that variability. How does it do it? What's it doing? Well, I'm not going to pretend we know 100%. In fact, that's one of the cool things about psychology being such a young science. There are still many questions that we're trying to find really good answers for. But in this case, I think we kind of have an idea, and we've went through some ideas. So there'll be something called template theory that I won't discuss, but it'll be featured in one of the videos I point you to at the end. I am going to move towards prototype theory and this notion of fuzzy prototypes, because this is what we really think is happening now. Now we're going to get a little abstract. I'm going to bring you into the research world. In the research world, of course, we don't use things like chairs. We want to create new concepts ourselves, and we often want to use relatively abstract things that don't have too much baggage associated with them. So here's an example of how people study this in the lab. They will create what's called a prototype. Nothing really special about the prototype to start with. It's just some, in this case, configuration of dots. But then what we do is we create slight distortions of this prototype. So think of this as your average chair. If you took every chair in the world and averaged them together, you'd have some prototypical chair. But now any specific chair is not exactly this chair. Slight little features are changed a little. So in these distortions, we take some of these dots and we move them a little bit. And for each distortion, we move different dots different ways. And so we end up with these, what are called exemplars. And just worry about the left side of this screen for now, just over here. We end up with these exemplars. So there's been a number of experiments that have been done with these exemplars. One I'll tell you about is if you show people exemplars that were derived from a prototype like this versus others that were not. They still have dots, but they were not derived from the prototype. They're not all similar to a common prototype. And now if you ask people which belongs to which set, you just kind of say, some of these are kind of like a family and some are not. So decide whether specific ones are in the family or not. People can recognize the family. They don't know what it is that defines the family, but they can recognize these exemplars that were based on a prototype and discriminate them from ones that were not. So something is getting through. As they see these things, they are kind of learning the average prototype that they were all derived from. And they're kind of seeing that resemblance on some very low level. In fact, if in one of these memory studies you actually present the prototype, even if you never presented it during study, so you never showed it to them until you're saying, hey, is this one of the family? People will very strongly endorse the prototype. They'll say, oh yeah, absolutely, that's one of the family, even though they never saw it before. So the point of all this is kind of as you're viewing all these different chairs, there is an average chair kind of being formed in your mind, and an average bird, and an average table, and an average female, and an average male, and an average any concept that you can think of. Microphone, computer, sneaker. I could go on and on and on. Take any object in the world, any concept even, like a relationship, an average relationship. What does that look like? Any concept you can think of as you experience these exemplars through life. So as you see each different dog, let's say, you are gradually building up in your mind the average dog. Okay, some concept of an average dog, and we call that the prototype. So other studies that have now done the same kind of thing, they've established a prototype by showing exemplars. And then if they just say, hey, is this part of the same concept as the prototype or not? What they've shown is that the more similar, so this is a low distance, it's quite similar to the prototype. This is a high distance. It's kind of portrayed over here, how far away it is from the prototype. If you present these and you just ask people to make a quick decision, member of the same family or not, but as quickly as you can, the more similar an item is to the prototype, the quicker people are. So for example, imagine instead of this abstract world, we had birds. And we had some notion of the average bird. Now if you showed people pictures and you said sometimes it's going to be a bird, sometimes it's not, and I want you to decide as quickly as you can, bird or not. Okay, you're making bird or not decisions. If I show you something like a robin or a crow or a sparrow, you're going to probably be very quick, because those birds are probably very similar to your prototypical bird. But if I showed you a penguin or a rooster or something like that, something that's not really, or an ostrich, something that's not really your typical bird, you find that people take a lot longer to say, yes, that's a bird. And so the notion we have is that when you see objects in the real world, let me just go back. When you see objects in the real world like this, every time you look and attend to an object right over here, let's say you figure out what that object is, you attend to it, and it's being matched to all these prototypes in a sort of fuzzy way. And whichever one it's closest to, that's what springs into your perception. That's what you see it as. So, you know, for example, even if we go back to our friend the ukulele here, it's kind of guitar-like. So it's got a lot of features that are very similar to a guitar. So it would be similar to both the guitar prototype and the ukulele prototype. But it would be more similar to the ukulele prototype simply because of its size. And, you know, I highlighted the 4 strings. If I saw 4 strings on this, I would really say ukulele. If I saw 6, I would be like, could be a very small guitar. You know, that's the kind of idea of how you could refine the perception of something afterwards. But like this, that's a purse. This is a vase. That's a television. This is probably a VCR. No, this looks like a VCR. This is probably a TV cable box. You know, and so literally as we look around, it's just like, what do I have in memory that's very similar to that? This is a almost beautifully prototypical lamp, so we'd have a really easy time figuring out what that is. If we go back to this one where I said, what the heck is that? You know, I now think it's kind of like a chest, and it's sort of a prototypical chest, but it's kind of weird too. You get the idea. That's how we think it works. All right, so what about when things go wrong with this step, the mapping the features to some memory representation? Well, I've already told you one situation, the man who mistook his wife for a hat, that thing that we call visual agnosia. Remember the glove, where somebody could see a glove perfectly well, but they could not recognize it as a glove. That's what happens when this part of the process, a part that we know is associated with association cortex, right? When that part of the process goes wrong, you get things like that, where they can see perfectly fine, but they can't recognize what they're seeing. I wanted to tell you about another kind of funny version of that, or funny, I don't know, it's not funny if you have it, I guess it's an interesting version. There's something called prosopagnosia. So this is me, and this is somebody I'm very often confused with, Johnny Depp. You know, we're so similar in so many ways. Sorry, I have to have a little bit of fun doing this, right? But I want to kind of be semi-serious, because I did happen to pick pictures where, in some ways at least, we have a resemblance. If my sister suffered from prosopagnosia, which is caused by damage to a very specific part of the brain called the fusiform gyrus, if you're interested, go check it out. But that part of the brain seems to be the part we use to bring things together into a gestalt, into a whole. And a face is very, you know, if you look at eyes, there's nothing particularly distinguishing about a person's eyes, or a nose, or a mouth. What defines a person is the way it all comes together to form a specific face. When somebody has prosopagnosia, they lose that ability to bring everything together, and they lose the ability to recognize faces. They can still feel the familiarity, but they can't recognize the face, a very specific kind of recognition, visual recognition deficit. So if my sister had this disorder, and let's say I went and stood at the foot of her bed, but then was perfectly still, I didn't say anything and I didn't move, because my speech or my movements she might recognize. But if I just gave her my visual look and she saw me at the end of the bed, she might say something like the following. You know that guy there? He's very familiar. I know who he is. He could be my brother, or he could be a movie star. To her, it's the same thing. I am the same as Johnny Depp to my sister. That sounds nice, right? But they lose the ability to recognize the identity. So they still get the familiarity, but not the actual recognition. Another example of how critical that recognition process is. All right, so some follow-up things that you want to check out because I think they're kind of cool. There's a video of somebody with visual agnosia, again, just to give you a nice concrete sense of what that's like. And this person will describe, when he looks around, he sees colors and shapes, but he doesn't see objects. He doesn't recognize what he's seeing. So a real powerful presentation of that. Similarly, a presentation of somebody with prosopagnosia, what I was just talking about, the lack of an ability to recognize faces. I threw this one in because it's just a head scratcher. It's a really fascinating opposite of prosopagnosia, just to show you how complex visual perception can be. People with Capgras delusions, they can recognize people, but the people they recognize don't feel properly familiar. So there will be people who say, that person over there looks like my spouse, they talk like my spouse, they act like my spouse, but they don't feel right to me. They're not my spouse. And they will begin to feel like this person's an intruder, that either they're a robot that's been made to look like their spouse, or they're an alien that's somehow taken over their spouse's body. People with Capgras delusions have been known to kill spouses and cut off their heads to prove to other people that they are a robot or they are an alien. They are that convinced that there's something not right about the person. So check that out. It's kind of freaky weird. All right, and I've put in a less freaky weird, more mundane, but theoretically relevant video that talks about this template versus prototype theory. In case any of that was at all confusing, this should bring it up. And I've got a reading about visual object recognition in general. So check those out, and also keep in mind, of course, when we're doing this, that everything I'm telling you about visual recognition is true of every sense that we think of. So for auditory, being able to recognize that as your spouse's voice or your brother's voice, or being able to recognize a particular singer or a particular sound of different guitars, for example, sound different to a trained ear. They can hear that. So all of this recognition holds for every sensory ability we have. I've just been focusing on vision to follow one through. Okay, that's all I'm going to talk about. Next lecture, we're going to talk a little bit about another critical thing, which is where the stimulation is coming from. All right, that'll be next.